All right. Hi, everybody. Mr. Couillard here, and I just wanted to do a quick walkthrough of the simulation and the software and the spreadsheet and all the stuff that you need for your summative test next week. And so, what I want to do first is walk you through the practice version, which is measuring the force of gravity on a bucket, and we're going to be using a bucket of fresh water and going to be doing this on Earth. So that is the same parameters that you have for your practice test. So when I'm done with this, you should be able to compare your numbers to my numbers and see how well you did. We'll break this up into a couple parts. The first part of this will be just collecting the data using the simulation, and then I will do a part on the graphical analysis that will be separate from that. So we have a window open with with the simulation force of gravity on the bucket lab. We have this set to, by clicking on the bucket, what the bucket's filled with, we can set it to what you need it set to. For this practice one, we're going to use fresh water, and then you can set it for whatever planet, asteroid, or moon you are assigned to. Again, for the practice, we're going to be on Earth. So on the day of the test, you will be given two things. You'll be told what your bucket's going to be filled with, and what planet, asteroid, or moon you're going to be doing it on. And so you need to make sure before you start collecting data that you have these set to the right things. Otherwise, you're not going to get the data that matches your test. So for this practice test, we're all using freshwater and earth. And so we can use the reset button and the pause button to stop time. So if you mess up, you can just hit reset and start over if you want. And then the pause and resume you can use to stop the simulation or pause the simulation. Um, and so let's pop over to we want to set up our data table first. So we have the title, Bucket Lab, my name, period, whatever period of the class you're in, and the date. I'm recording this on October 9th. And then conversion factors. So you are going to be asked to convert from milliliters to liters. So I've provided you with that conversion factor. If you don't have this conversion factor, or for labs in the future, you could look this up and do the conversion that way. But there are 1,000 milliliters in 1 liter, so we're going to have to remember that after we collect our data. So our independent variable, we are changing the amount of stuff in the bucket, and so we want to note that we are measuring in milliliters, which is a measure of volume. So I will type in volume. I'll even spell it correctly. Volume, and then the units, milliliters. Okay, and so that gives us our independent variable with our units. And now we are going to collect. We're going to collect data every 250 milliliters all the way up to 2 liters. So we will go so we'll go from 250, and we can go ahead and pre-fill these since we know all the marks on the thing. 750, and then we get to 1 liter. Don't get fooled here, because the simulation should really have everything be in 1 unit, but when they get to 1 liter, they switch, which I'm not a huge fan of. But if you're looking at the pattern, we're going up by 250 milliliters each time. So 1 liter is actually 1,000 milliliters, which we know from the conversion factor up here to be true. And then we keep adding 250 each time. So 1250, 1500, 1750, and 2000. So that's a good thing to note here. Everybody will be using the same bucket. Everybody will be filling it the same amount. So this part is actually going to be the same for each of you. What's going to be different is the forces on the sensor. So what we want to do next, we want to convert our milliliters to liters. So we want to convert to a metric unit. That metric unit is going to be convert to metric unit with a prefix. So that's going to be liters. Oops, need a space in there too, preferably. So this is, well, we'll just say volume in liters. Okay. And so now this is where our conversion factor comes in, right? So we need to convert from milliliters to liters. I want you to do this with a formula so that you know how to use formulas in spreadsheets. So all formulas need to start with an equal sign. So we're going to do equals, and then we want to convert what's in column A. So it's A and then the number 9, since this first measurement is in box A9. And then we want to convert it using the 1,000 milliliters. So, oops. And then so we're going to do, and because we're going from a smaller unit to a larger unit, we're going to divide by the smaller unit. So it's going to be divided by the conversion factor, which is located in D2. And don't forget to use your dollar signs to lock in that that one square. So even if we copy this formula, it will always remember to use D2 because that's where because that's what the dollar signs tell the spreadsheet to do. So A9 divided by $D, $2, and that gives us the 250 milliliters is 0.25 liters. And so we can, I want to format that to be aligned. We want to have that aligned in the center. I just like the look of it. Everything's lined up nice and a little neater. And so now we can do this for all of our independent variables. And to do that, we can just copy. So I do Control C and Control V, and that will copy that. Control C, oops. We want to Control C, Control V. You can also do that up here. You can go under Edit, Copy, and then select where you want to copy the formula to, and you can do Edit, Paste. You could also see this little blue corner here, and you can just drag this down into the rest of the column that you want to paste it into. All right, we want to make sure that we have the same number of significant digits in our original measurement. So we have, let's see, we have, let's set this to do 3 sig figs. So we're gonna, to change the decimal places, you want to use these 2 buttons up here, increase or decrease. So we want to add a decimal point. Oops. Let's see. We want, how many do we want total? I'd say let's go with 3 because this is 250. So yeah, I think 3 would be, yeah. So 2 on this would match this. So 2 decimal places I think is going to be perfect. All right, so we have our independent variables all set up. We have them converted. We have them in milliliters in the first column. We have them in liters in the second column. That is exactly what we need to see. So now we want to collect our dependent variables. So to do that, we're going to go back to our simulation. Oops. And we want to reset this, and then so we want to pause it every time it gets to one of the marks on the bucket. We want to hit pause and then take a measurement. So let's we're going to reset. And pause. Okay. You may want to do this a couple times to get it, to practice it. Okay. It's probably close enough. And again, it's important if you're, by doing 3 trials of this, you're going to account for the fact that you can't exactly click on it the exact same moment every time. Try to get it as close as you can. It'll improve the quality of your data. You don't want to be sloppy or careless about when you're clicking. But to some extent, doing 3 trials will kind of statistically strengthen the quality of your data. All right, so we're at 250. Let's see what our first value is. So we click on the black box, which is the force sensor, and it brings up the other. It brings up the digital readout, and we kind of watch it for a second. This is a measurement of force measured in newtons, and it kind of hovers around 379, 38. Let's go 379. That last decimal you may estimate, so we're going to click back and put 379 into trial 1. All right, and then we just keep going, right? So now that's for 250 milliliters. So we click on the sensor, go back to, and then we're going to hit resume and let the bucket fill up to 500 milliliters. And again, you may have to, if you have to reset it and try it again, no worries. All right, so then we're at 500 milliliters. We'll click on the sensor, and now we're at, let's see, 6.29. Again, it's always going to be between 2. Don't sweat that too much. Just make your best estimate, which is what we have to do in the real world. All right, so let's keep on going. Let's go up to 750 milliliters, 750 milliliters. Pause. And now, and at this point, it's just repeat. You get the technique down. That looks like it may be 8.93. It's always going to float a little bit. Don't worry about that last decimal point. It's probably not the last decimal place. Actually, probably it really isn't going to be that significant. All right, keep on going. Let's go up to 1 liter, 1,000 milliliters. And again, you want to be as careful as you can. And let's see, what, 4.8, 4.6. We'll do 4.6. All right. Keep on going. We're going to go up to 1.25, 250, 1,250 milliliters. Boom. All right, good. Flip on over, and we're going to do 13.83. All right. Or 8.4, 8.3, 8.4, 8.3, 8.3. You can. And let's see, now we're going to click on back. We're going to do this up to 1,500 milliliters, which is 1.5 liters. And we'll click over to 1605, 04, 05. 1605. All right, 2 more to go. Click on up, pause. 1750, 1.75 liters, and we're at 18.770. 7 ones. Ooh, let's do 70. 1870. It's kind of bumping all over the place. We want to bump out one more decimal point to keep them all with 2 decimal places. All right, so last one, 2 liters, and we'll get that to be, okay, 20.997, 93, 97. Yeah, okay. All right. So that is our first set of data. So then you would, to collect your second set, you'd hit reset, and you'd begin this again. And once you get the pattern down, it shouldn't take you too long. It's a little detail oriented, maybe a little tedious, but I think it should go pretty quickly once you understand how the simulation works. For the purposes of speeding up this video, I already collected the 2 other sets of data, so it's kind of like the cooking shows where they put something in the oven and then they take the pre-cooked thing out so that audience doesn't have to wait for it to cook. So I'm going to tab over here and grab data that I already collected for this. And so I will copy that data and then we'll bounce back to, and this will just save us time because you don't want to watch me do this 2 more times, I'm pretty sure. So we'll just paste that data in, and okay. So the simulation is good about making it feel like this is realistic data, in the sense that it does vary a little bit, like it would if you were in the lab taking this data. Even if it's an electronic sensor, it still doesn't sit just on one specific number. Okay, so now we have our 3 trials. From the bucket, you saw me do 1 set, and then you'd repeat that 2 more times. And so this is a typical set of data that you'd get. Again, this is customized to the fact that we're using fresh water and that we're using it with the strength of the Earth's gravitational field. So your numbers are going to be similar. They should be in the ballpark to these, but they're not going to be identical. They could be, depending on the strength of the gravity, they could be stronger or weaker. Also, depending on the density of the material that you're using, they could also be larger or smaller. But it makes for good data. So we're going to average this. So we're going to use the average function in the spreadsheet. So we're going to do equals AVERAGE, open parentheses, and now we want to tell it where to grab the averages from. So we want to do from C9 to E9. So we're going to do C9 colon E9, close parentheses. And it will put a little box around that data so you can double check it before you hit enter. Okay, and so there's our average. And again, we're using formulas so that once we've set it up once, we can copy it. Control C, Control V, or you can just pull in this corner and just drag it down like so. Now notice when we do this calculation, we get a whole bunch of different decimals, and we want to. Most of these extra decimals aren't valid. They're not accurate. They don't mean anything, essentially. They're an artifact of the calculation and the artifact of doing the division, essentially, the math. And so we want to clean this up. So to do that, I want to, let's see, we want to highlight, let's highlight the whole thing, and then we can go under Format and Number and parentheses. So number, if we click on that, it defaults to just 2 decimal places. And that's as accurate as our average needs to be, because that's as accurate as our data is. So yeah, so this is a good looking set of data. We have our independent variables in 2 units, both metric, milliliters and liters. We have our dependent variables, 3 trials, and then the average of those 3 trials. And so that average is really going to give us some confidence in the quality of this data. So that's the end of this part of it. So we went over how to use the simulation, how to collect the data, and then how to put that data, the independent variables and the dependent variables, into the spreadsheet, how to convert it from one unit to another unit using a conversion factor, and then how to clean up the data to the correct number of decimals or significant figures. Yeah, so tune in for the second part of this, where we will we'll actually plot this data and see what our line of best fit looks like, see what our trend line is, calculate the slope, and create the equation. So I hope you guys tune in for part 2.